All right, everybody, we are going to get back to what we were doing here. We have another presenter for you all. Our next presenter is Meg Carter. She's the Conservation Science Director at the NorthWoods Stewardship Center. Meg has extensive experience with the installation of bioengineering projects on lake shores around the state, and she's going to take us through how these projects work and how to install them and give us some great case studies. So thanks for being here, Meg. And if you can share your screen, we'll get going.
Okay, can you see my PowerPoint here?
It's just black right now.
Okay, I'm gonna turn off my camera because I'm a little bit slow on the internet today, so we'll just see the PowerPoint.
Oh, there it is.
Great, cool. Speak up if you lose me. Okay, my name is Meg Carter. I'm the Conservation Science Director at the NorthWoods Stewardship Center. We're up in the Northeast Kingdom of Vermont. We're an environmental education and conservation nonprofit with the mission of connecting people and place through science, education, and action. And today I'm going to talk a little bit about bioengineering practices and some specific projects that we've partnered on around the state of Vermont since about 2017. Most of these were implemented using our youth and adult work crews that we field, as well as really important partnerships with a variety of conservation organizations and equipment subcontractors around the state. So first I'm going to dip into what bioengineering is, which is the application of engineering principles of design and analysis to biological systems. And I want to give the caveat that I'm not an engineer. I like their style. So we have heard of probably biomedical engineering, which is a branch of bioengineering that uses body processes to achieve medical goals. The bioengineering that we use for water quality projects has a similar philosophy, but uses the inherent properties of plants, soil, stone, decomposition, and so on to create resilient shorelines. You can see in these two photo examples here some different shoreline management practices that are failing or definitely will fail without constant upkeep. The seawall structural approach to shoreline management has a tendency to be undercut by continuous wave action and will eventually fall down, causing potentially more problems than it solved. The other photo shows a sloughing bank that has no woody vegetation on it. Using observations of how and why these different types of shorelines tend to fail and contribute to poor water quality in the lakes and rivers they're adjacent to, we can adjust our management practices to set ourselves up for success in the long term. And we can sort of extrapolate the bioengineering principles from observations of how and why these projects tend to fail. So if we observe that hardscape shorelines tend to be undermined by wave action, constitute a barrier to wildlife, and contribute to a redistribution of lakeshore issues such as flooding and erosion, we can draw that softer shorelines, maybe more complex shorelines, tend to be better for setting ourselves up for success. If we observe that unbuffered shorelines tend to be more susceptible to wave and ice pressure and contribute large amounts of sediment into aquatic systems, causing water quality issues, we can conclude that using woody vegetation and really trying to establish root systems in our shorelines can help make them more robust. If we observe that steep slopes tend to settle into shallower angles where they become more stable, as you can see in the slumping, we can conclude that there is a natural angle of repose that slopes, depending on the material that they're made of, tend to like to fall into and require less energy to maintain. So some of the goals that a lot of these riparian bioengineering projects have broadly include having resilient and stable shorelines that will stand up to water, ice, and recreational pressure, having diverse shoreline habitat that contributes significant ecological services to both human and non-human inhabitants and users, They use native species to support co-evolve to native species, like Annie White will talk about later. They have robust shoreline vegetated buffers that will act as effective biofilters and treat stormwater runoff to reduce negative water quality impacts. And then over the lifetime of a project, we want to need to do very little in terms of disturbance or maintenance. So green practices tend to maintain themselves as roots reach for water, soil and duff build up beneath vegetation, cooperative and competitive pressures between different species and individuals, and non-biotic elements shift the composition of the buffer and the structure of it. And then lastly, we want to contribute to an updated aesthetic that isn't lawn to lake or park-like, but embraces what might look more chaotic, but is actually more complex and perhaps healthier. In this photo, you can really see the difference between seawall shoreline and the more natural lake-wise shoreline. You can see the lake-wise sign in this picture. So the natural shoreline has a multitude of benefits, including being more accessible to wildlife, unlike the seawall. It has a well-established and deep root system to provide soil stability and biofiltration, unlike the seawall. It has overhanging vegetation for shading, habitat complexity, and fish food, including protein necessary from dropped insects from those overhanging branches. The establishment of shoreline restoration projects that have these characteristics of a natural, stable shoreline is something we can achieve or aim to achieve using these bioengineering techniques, which include having a vegetated buffer. So these techniques are not necessarily one-off things or entire projects in themselves, but are often used in concert as tools in the tool belt across an entire project. So you could have, for example, encapsulated soil lifts that also incorporate live stakes and pretty much endless variation. I'll get into these a little bit deeper later, but just to give you a quick idea about each of these, a vegetated buffer is an area around a body of water that has mature vegetation that's beneficial in terms of habitat and water quality. Lawn grass definitely does not count. Slope regrading is taking a slope that's at an unstable angle and scraping it back to a shallower, more stable angle, or if there's enough space on the site and there's no use conflict, sloping out into the water. But it's preferable to slope back in terms of permitting and making sure you're not encroaching on the water. You can build encapsulated soil lifts, which can help you create a slightly steeper angle than what might be an angle of repose, but it allows you to establish root systems within that practice because the biodegradable materials will hold that slope together. A vegetated geogrid is pretty similar to an encapsulated soil lift, but it doesn't have the coir log. Live stakes are cuttings from dormant woody plants that have a propensity for rooting from cuttings, such as willow species and dogwoods. They love to root. Live crib walls are a technique that I don't personally have any experience with, but they're wooden constructions on a shoreline with openings that woody plants can establish in. And it has that same principle of biodegradable materials and the establishment of robust root systems as those materials biodegrade. A stone toe is a protection, stability, and elevation practice that can absorb wave energy, redirect ice push, and give flat surfaces to build a practice up on, such as encapsulated soil lifts. And they have a complex shoreline structure that isn't an impediment to wildlife passage. So this is a confusing project type. And I'm going to go through the steps for how to put together encapsulated soil lifts, but it's one of my favorite project types, and we have a lot of examples of successful implementation of this project type throughout the state. This is kind of my MS Paint version of a cross section of an encapsulated soil lift project, and we'll see much better examples of this later from people who actually know what they're doing using CAD. This is just to basically show you, if you dropped a pin from the top of an encapsulated soil lift project through one level of the lift, these are the layers that you would hit on the way down toward the ground. And I'm not going to get too deep into this because there's better things later. But I want to talk a little bit about the bio-D blocks that we use in these projects. So the bio-D block is the taco shell to the stack of tacos that is the encapsulated soil lift. And they're made from woven coconut fiber from the husk of coconuts that's tends to be imported from Sri Lanka, and they're very difficult to describe. So I'm going to show a couple photos of some so you can get an idea of what they actually look like, and maybe understand a little bit better how they can be used. These are two photos of the same encapsulated soil lift bio-D block, and it's shipped and sold condition. So they're a combination of erosion control blanket and a flattened fiber core log. The blanket is folded up on itself and tied to itself in these photos. So you can see the ties on it in the photos holding the blanket together so that it can be shipped as a neat package. The log is 10 feet long, as you can see on the left. It covers about 10 steps and 12 inches high. So the log itself is 12 inches when it's sitting up on the ground. Each of the logs is slightly different from one end to the other. They're not totally symmetrical. And they're like this so that they can fit together with an overlapping blanket flap. You can see the photo on the left has an outie section and the photo on the right has an innie section. So you put the outie section into the innie section and you tie the blankets together, and it's this modular project type, so you can create lengths of this pretty much as long as you want. To open the blanket, you have to untie or cut these knots that are along the whole length of the log, and this is the start of the opening process. This is the blanket partially flapped out, and here's the blanket fully flapped out. So it's like a hot dog with a really long flappy bun. Here you can really see on the photo on the right, the innie end of the log where the outie end of the next log in the lift would attach. And there's the innie end again. So here are some of the projects that we've been part of implementing throughout Vermont over the years. This project on Black Pond in Hubbardton is about a 300-foot length of Black Pond Road that was seeing a lot of erosion into the pond. Across the road from the pond is a very, very steep, stony hill, so it's not feasible to move the road over in that direction away from the pond to eliminate this conflict. Building outward from the road edge is also a major challenge here, because the steepness of the slope continues into the pond. So it gets very, very deep very, very quickly. So we had a very small space to work in, bounded by hard limits on either side of the project. This is something that the encapsulated soil lifts are well suited for. They can allow you to build that slope that doesn't quite match what you'd expect to see as a stable angle of repose, but you get the root systems established that will hold that slope together. So when we're installing these, our first step is to put in a turbidity curtain, which is this floaty yellow guy you can see on the edge of each of these photos. This has to happen before any digging or potential sedimentation from project construction. They'll usually sit about 6 to 8 feet off the shoreline, and this style of turbidity curtain have a dangling vinyl-looking curtain that prevents sediment from the project spreading out into the water body at large. Doesn't mean that we're throwing soil clods or rocks in the water on purpose. We just we have to be careful about that still, but this prevents wider damage out into the rest of the water body. Once the turbidity curtain is in place, we have our partnered or contracted or rented excavator and operator start excavating a shelf to build on. These projects really need this machinery for installation because of the sheer volume of material removed and the likelihood of running into large stones or other obstacles to hand tool usage. In this case, the town road crew and their excavator were available and did the excavation as in-kind match for the project that they were benefiting from. The black fabric you can see here is a non-woven geotextile fabric, which allows the passage of water through it, but not the passage of sediment. So this is placed on the shelf, and then you build your stone toe inside of it and then flop the top over the top of your stone toe, which is open to the water. So this is another taco in the stack of tacos. This first photo on the left is the building of the stone toe. This provides stability to the base of our lifts, protection from wave action and ice push, and elevates our base lift above the mean water level by about a foot. And as I mentioned, it doesn't constitute a barrier to wildlife. Once the stone toe is down and the other half of the geotextile fabric has been flopped over the top of it, we can set and install our first lift. We set the front of the log a little back from the front of the stone toe and lay down the lower section of blanket, tying the logs and blankets together using the lengths of coir rope that often come inside the log itself, or you can also use a 1/4-inch natural fiber rope. Once the lower blanket is down, we add a second layer of erosion control blanket inside the Bio-D block. In this case, it's a straw blanket with cotton strings holding it together. Some kinds of erosion control blanket have what's called photodegradable plastic net holding them together. That's that green, plasticky looking stuff. But that is very unfriendly to wildlife, and I highly recommend that you do not use it. Use this cotton one instead. One very nice thing about these encapsulated soil lifts is that the material is so flexible, and it can be easily keyed in to the existing soil and made to have a more organic, less severe shape, and can flow around features that you want to keep in your landscape, like trees, which you'll see in one of the future slides. So far on this project, we set up the turbidity curtain, dug the shelf, laid down the block and blanket. We laid down the second layer of erosion control blanket in the Bio-D block, and we leave the upper blanket that's attached to the block flopped out toward the lake, and also the outer 4 feet of the second erosion control blanket flopped out toward the lake over top of our log. So we have 2 layers of blanket ready to have soil placed in them, and we're holding the coir log vertical there on the lake edge of the project. We also, at this point, tuck the root balls of our woody plants underneath the block so that the whole root ball is just on the upland side of the block that we're holding vertical. It's a very interesting process to be part of and to watch, and also a very difficult process to try to describe verbally. So if there are questions, I'll be happy to address those later. We usually get about 3 people kneeling on the water side of the block and holding it vertical and in place while the excavator layers a few inches of soil into the lift and then tamps it down with the bucket. You don't want to tamp too hard. You don't want to be creating impervious surface here, but you do want to make sure that you're pressing out voids so that your soil lift stack doesn't collapse like a souffle. We usually have grub hose, which you can see in the photo in my hand there, to spread the soil out into a few inch thick layer so that the excavator can tamp it for stability. The compaction toward the edge, toward the log side, is much less. So we usually use the grub hose to tamp that down and press out voids there so that the excavator bucket doesn't collapse the edge of our practice. This team on the left is spreading the soil out with their grub hose, since the excavator can't tamp too close to the block. So you can see that there. They have to be pretty careful to keep the block vertical, because if it starts to slump outward toward the lake, it won't hold the soil in as well, and it'll strain against the stakes that we put into it afterwards. So you want to try to have back lean, if anything, and not outward lean. You can, if you end up with some outward lean, you can often address it with some creative whacking and potentially some beefy staking, but it's best to just have that practice be vertical from the get-go. The second photo here is after the topsoil has been placed in a lift, lightly tamped, and then the outer third, the watermost third of the top of that soil had been seeded with wildflower seed. And then both blankets had been flopped back over away from the water and staked in place with 2-foot hardwood grade stakes. You sometimes need to cut some of the upper part of the stake off if you hit something under the ground, because they can be pretty major tripping hazards, and sometimes the entire length of it won't go in. But the top nub of the stake from a lower lift can help hold your next lift's lower blanket in place, so that's pretty handy. Depending on the project specs for the target slope, you'll set your next lift back from the front edge of the one below it, usually by about 1 foot or 18 inches or maybe 2 feet. And then you repeat the process of laying down your blanket, tying your bio-D block together, rolling out the erosion control blanket, tucking in your root balls, kneeling your crew in front of the log and having them hold the block vertical, pouring in the soil, scraping it around, tamping it down in lifts all along the whole length, seeding the water side 1/3, flapping the blankets over and staking in place. So that whole process, you repeat each lift up that you go. The top lift blanket, the one at the very top of your practice, you can plant into that, which sometimes means cutting through some of your erosion control blankets. And we usually try to do that in a way that doesn't interrupt the function and stability of our stakes holding the blanket back. So you don't plant directly lakeside of a stake that you've put into your blanket. And the top lift is the only one that gets fully seeded over the top of it, because the other ones have a lot of soil on top of the back 2/3 of them. So that would be a waste of very expensive seed potentially. So the labor for this project cost about $20,000. And I don't have an exact number on the materials, but I believe it was about 20,000 or potentially a little bit more. Once the project is complete and any sediment inputs have had a chance to settle, we carefully remove the turbidity curtain, and in this case, we were able to use the excavator to pull it out over top of the project without disturbing the lifts. And we also had the added benefit of dripping some water onto our practice, so it was kind of an initial watering of the lifts as well. Post-installation care for these practices is very, very necessary, especially watering the plants. And then also installing temporary fencing and putting up informational signage can be very important to prevent trampling and to help educate the public about why it is these practices have been installed where they are. These actions can give the project a greater chance of success and increase public acceptance of the project so that it's not rejected or torn out. This is the much better side cross-section of the encapsulated soil lifts that I was talking about earlier. This one is from Annie White, I believe. So you can see the stone toe here sloping up out of the water. Our first encapsulated soil lift sits on top of that with plants underneath it, and then stacking up and moving backward from there. And this was for the Lake Bombazine encapsulated soil lifts, which was done in the town of Castleton that Laura actually talked about earlier. You can see the progression of this project as it goes from pre-installation on the left. You can see that steep, unstable slope, not a whole lot of vegetation. A lot of the vegetation that was there was actually invasive species. I believe there was quite a bit of honeysuckle. And then you can see during installation in the second photo. The next photo is, I believe, 1 to 2 years after installation. And then the fourth photo is, I believe, 3 years after installation. We installed this in 2017, I believe, and it was a 2-week project. The first week was doing initial site work, closing down the road, and I believe the Vermont Youth Conservation Corps did a lot of the stone toe installation and the turbidity curtain installation. And then there was a big push. It was kind of treated as a training where a lot of folks from around the state came and helped install the first round of encapsulated soil lifts on this project. Yeah. This is a 2021 photo of that project, and you can see a lot of the vegetation in there has done really, really well. And someone built a deck over it, which is just fine. This photo on the left I really like because you can see the function of that turbidity curtain in action. The project side of the turbidity curtain, you can see quite a bit of turbidity. And on the outer side of it, you can see that the lake water is clear and all that sediment, which I think is mostly rock dust at this point, doesn't travel out into the broader lake. And then on the right is my crew, and I'm just so proud of them. They were great. This is the installation around an existing willow that was in place on this bombazine project. And as I mentioned earlier, this project type, this material type is so flexible and versatile that we were able to incorporate the willow into the lifts that we made, and it was able to survive through the installation of this practice. I'm going to go through a couple more projects, but I'm going to do it relatively quickly, not quite as much description. I do want to highlight here that working with really great designers like Annie White at Nectar Landscape Designs, Wind and Water, Patrick Hurley with Wind and Water, and Holly Greenleaf with Greenleaf Designs is so wonderful because you get not only a great description and set of instructions for what you're going to be doing, but also some really beautiful artwork as well. This project here was done in partnership with Essex County Natural Resources Conservation District, DEC, and Nectar. And you can see that there was a failing timber wall that was going on this shoreline that needed to be replaced so that it could have more longevity. This is a part of the lake where the lawn was probably 6 or 8 feet above where the water line was. So we installed the turbidity curtain around the future project site. And then Johnny Cunningham, who I believe is here today, did some expert excavation, gave us a really nice stone toe to work with, moved a lot of soil for us, and even got out and did some raking as well. The team put in the coir logs. I think we did a stack of 3 here. Yep. And you can see that some of the cedars that we ended up having to take out of the wall in order to remove the timber wall were placed back into the encapsulated soil lift project. And this is us at the end of the project. And then this is a few years later. I believe this is 2022. And the project is doing really well. Definitely a lot more stable than the former timber wall had been. This is another project we did, very similar, private lakeshore project over on Caspian Lake with Orleans County Natural Resources Conservation District and Wind and Water as the designer. This was installed in 1 day, which is a major contrast from the Black Pond project, which was a 300-foot project you saw before. That took about 2 weeks. So it's highly variable depending on your size. This project type is very modular. You can install something that is a stack of 4 high and 1 wide, or a stack of 2 high and 50 wide. It's very, very versatile. And this is a very nice cross section of the project that you can see here. You see the stone toe, you see the stack of bio-D blocks and the vegetation in between, and then incorporating other vegetation around the project. This Millbrook vegetated geogrid, this is on a river, so this is sort of a similar project type, but a different application. And you can see that the erosion control blanket doesn't have a block associated with it. So it's just one or more very, very long length of the woven erosion control blanket that we can put around corners. And this still has a stone toe, but also to key it into the existing bank had several root wads attached to it as well. And this was done in partnership with the Upper Missisquoi and Trout River Wild and Scenic Committee and a private landowner as well. And you can see we installed about, I think it's 5,500 willow whips as we were installing these lifts around this riverbank. And it really did a great job of creating a more stable slope, establishing that vegetation, and working with the processes of the river rather than trying to just rip-wrap it and hold it in place. And this is sort of an artistic cross-section of that. This is another project we did up on Lake Salem by the Coots Moriarty Camp and the Town of Derby Beach House. This drawing was done by Holly Greenleaf. This is the concept drawing for the project. And this one was particularly interesting because there's a lot of recreation pressure on this part of the lake, but there's also quite a bit of ice push, which was causing some problems on the edge there of the recreation space. So we wanted to, this is a photo overlay of the space. We wanted to make sure that there was still recreation access, but also that there was some more vegetation installed here for the biofiltration purposes and to hold that edge together. And to beautify the space and help put in the public eye sort of a different approach to this public recreation space. And you can see we installed the turbidity curtain and then sloped back the crumbling edge there. And then installed a coir log, which this one, the height of the slope, the height of the finished area was low enough that we didn't need to create the stacked lifts. We really just wanted to stabilize the base of that slope and help protect it from ice as our vegetation was establishing. So we installed that log without the attached erosion control blanket. But you can see we did put down that straw erosion control blanket to hold the soil in place as our seeds started growing and as our planted shrubs and perennials grew as well. We installed a split rail cedar fence on this project because of the intense recreation pressure from humans, and also you can kind of see down toward the bottom, we installed a chicken wire fence to prevent dog trampling as well as human trampling. And this is kind of late in the season to see how lush the vegetation is, but it really started to come together. And this is, I think, 1 year, no, this is 2 years after the initial installation of this project. Here's another project over on Maidstone, another private landowner, and this is another coir log rather than the encapsulated soil lift projects. And this one was designed by Annie White from Nectar and done in partnership with ECNRCD and DEC. You can kind of see what the problem was here in this photo. It was intense ice push, just getting under and then lifting up pretty much this entire lawn and taking a lot of sediment back out with it. So the plan here was to slope back the lawn, which we did by hand, and then install a bit of stone protection around the base of this lawn area, and then install a fiber core roll at the edge of the shore to try to get the vegetation established on the lawn side of this project. It was also a lawn to lake project. Originally, it was lawn to lake, and we wanted to make sure that there was some robust native vegetation happening. And then also the photo on the left, you can see we created a grassy path down to the lake because this was the project was on the land of an elderly gentleman, and he also had an elderly dog who liked to get into the lake and just bark at frogs. So we wanted to make sure that it was still accessible, but also beautiful. And Annie did a really, really beautiful job of designing this project. And here it is a couple years later. Still going strong, a lot of great vegetation in this area, yeah, held up really well. So some lessons learned over the course of our time doing these bioengineering projects. We learned that post-installation watering and care are so important. You really want to make sure that you're protecting your investment and doing the small things that can really set you up for success in the long term. Invasive species treatment really needs to occur so that you can prevent that opportunistic takeover, and it's another way of protecting your investment. You don't want the plants that you're putting into these projects to be outcompeted by invasive species that don't serve the ecosystem functions or the physical functions that we're looking for in these projects. Plan follow-up visits and maintenance annually until the practice is well established. So that includes replacement planting, resetting ice damaged project parts, etc. We like to do what we call the 20-minute shovel treatment, where you go back to a project and you just see what are the small things that you can do to make sure that your project is living up to its design life, that it's still serving the function that it was set up to serve. Another thing we learned is that excavation services are incredibly important. It's really, really important to have great excavators, operators on site who know the principles of water quality projects and you can trust behind the joysticks, and who understand the importance of the work that's happening here. I favor wildflower seed over conservation mixed seed. It's more expensive, but overall serves broader ecological functions, really enhances the project beauty. It does cost more, but you're also not just introducing lawn grass into a project where you're putting a bunch of other native species. So it serves that purpose as well. Installing temporary or permanent fencing around your practices to prevent trampling or compacting, that's just also setting yourself up for success, trying to make sure that the hard work that you've done isn't being undone by recreation. And along that same line, making sure that the project that you're doing does serve the public in some sort of recreation capacity if that's what if that's what they want. For example, on the Black Pond project, the area that we put those encapsulated soil lifts in was really, really popular with anglers. So in order to try to enhance the success of the project and not have it be rejected, we provided several sets of stone steps so that there could still be recreational access to that area, but we were still getting the benefits of that water quality project that we installed. Along the same lines, installing informational and educational signage on projects that are on the public land or in the public eye can be really important. It's just trying to make sure that folks are on board with what's going on and can get behind it rather than fighting it. It's really important to use clean topsoil, sand, fill, or nursery stock and not be introducing invasive species into your project, going along with number 2 up there. And then also clean your turbidity curtain between each use because of the potential for spreading aquatic invasive species. That's bad. Thank you. That is the end. And if you have any questions, I'd be happy to take them.
All right, there's lots of questions. So this first one maybe is not really a question for you, Meg, because it's about CAD. And I don't think that you do a lot of bioengineering or CAD drawings, but I know there are lots of engineers on this call. So if somebody else wanted to answer this question, feel free to. And if not, I guess we'll just move ahead. But our standard CAD details for encapsulated soil lifts or other bioengineering projects available for engineers to download and use in their project designs. Anyone on this call have an answer for that? Okay, well.
Allison, I have a comment.
I was hoping you might answer something. Yep.
Yeah, it all depends on the slope you're dealing with. I don't think it's wise to assume you can apply a detailed drawing. It all, whether what the bank looks like, how steep, whether you need to grade it back, how many lifts you need, how high the toe needs to be. There's definitely detailed drawings that help send the message across, but I think, customizing it to the topography of the site is important.
All right. Thank you, Patrick. Okay. So moving on, you did get some love in the comments about all of your industry terms, the innies and outies and hot dogs and stuff. All right. Has the Black Pond soil lift project been in place for long enough to weather a heavy rain or flood? If so, how did it fare?
That is a great question. And I cannot say that I know. I haven't seen it in person since we installed it because it's down in Hubbardton and that's about 3 hours away from me. But if anyone has driven on Black Pond Road or gone by Half Moon State Park, you may have seen it. I haven't heard that it has been damaged in any way. And I think Janet, the road forewoman there, has since retired, so I don't actually have any connections down in the area. I'm really eager to hear if anyone knows if it's held up well, but I expect that it has, especially because the one on Cedar Pond Road down in Castleton on Lake Bomazine has, and it was a very, very similar project.
Okay, that's good to know. I'll actually add that to my list of things to try and look at maybe this summer. Next question, how long do you monitor the finished encapsulated soil lift sites?
So we personally, NorthWoods, are not responsible for much of the operation and maintenance of these projects. We usually leave that in the hands of the landowner or local partners. So there's really no associated monitoring per se, but we usually recommend that folks for the first year come back and water probably once a week if there's not a 1 inch or more rainstorm that's happened. And then we love to come in and peek at them every once in a while if we're in the area. But there's no rigorous monitoring that's encoded into the project.
Yeah, I will say we're going to talk about operation and maintenance for state-funded projects a little later in this training, but there are some moves within DEC to fund operation and maintenance for projects that we are funding and having agreements in place before projects happen for who's going to be responsible for that. All right, next, for the Black Pond construction, is a special O&M agreement provided? All right, this is kind of a very similar question, at least the first part. So we're going to talk about O&M later, but the second part of this question is any special instructions for the road grader or the snow plow?
Yeah, we actually built the project thinking about the plow because there's nowhere else for the snow to go except over that bank. So what we did was we made sure that when we put in the top lift, it was lower than the edge of the road. And we put in quite a bit of plant types that don't mind that sort of situation. So ones that if they're cut off at the top, they might resprout, and we added a lot of perennial vegetation as well. But also the work was partially done by the town road crew, so they're the ones who are going to come back and do the plowing, and since they were integral to the implementation of the project, they also have a vested interest in not destroying it. So they knew and could go forward expecting that they wouldn't be hurting the project when they plowed there.
Yeah, that's great. Communication and working together are big parts of all of these projects. Is there any issue with placing plants with root balls in the top soil lift?
No, that was actually one of the things that we did. That's when we cut the hole in the erosion control blanket. We try to cut relatively small holes, and then there's landscape staples that we use to try to put the erosion control blanket back together around the root ball. But it's actually one of the things that we tend to do is put the plants in the top layer of the encapsulated soil lift.
Okay. Can you talk a little bit about planning for higher lake levels, ice movement damage, and other increased storm events to the encapsulated soil lists?
Yeah, our hope is that because of the bioengineering principles that are at play in these projects, they're going to be resilient to future storms because they'll have these robust root systems established and in place. But with rising lake levels and that sort of thing, having the stone toe act as an elevating practice is going to help us mitigate that or any problems associated with that. And also the way the stone toe is sloped, it creates this sort of ramp to push any ice up and over your practice rather than having it shove into your practice and lifting your practice up. So the stone toe hopefully will be a protective practice and will help mitigate any problems with that sort of thing.
Does this practice, I'm assuming this is the encapsulated soil lifts on the roadside, allow stormwater to drain off the road?
Yes, it does. And you can see that both in the Black Pond one and the one on Lake Bomazine, because they're lower than the actual level of the road. And if the road is crowned, then it'll send stormwater into your practice. And because it's not compacted, the voids have been pressed out, but it can still absorb that stormwater that's flowing off the road. Yep.
Okay, we had a couple of questions about the turbidity curtain. So it seems like people are interested in understanding how you put it out and then also how you take it back in and where the sediment goes once you take the curtain up.
Yeah, so the turbidity curtain is a floating tube with a dangly curtain, and there's a chain attached to the bottom of that curtain. So the bottom of the curtain with the chain is weighted down to the floor of to the bottom of the lake or pond. And when you put it in, you sort of put it in straight on. So you send it out into the lake in kind of a straight line. And then you shuffle it into place. You float it into place, usually with someone wearing waders, although at Black Pond it was so deep that I went out just in my bathing suit and a life jacket to sort of swim it into place. And we installed it that way. You usually stake and tie the ends so that it doesn't float out into the lake, so it's attached. And then in your shallower lakes and ponds where you can often stake the middle of the turbidity curtain to sort of hold things in closer to the shore where you're working. When you're done, you can do like what we did at Black Pond, where you use the excavator to sort of lift the turb curtain out and pull it over your practice, so you're not disturbing soil on the shore, and you have that little added benefit of watering your practice. But for smaller projects where that's not an option, you just take it out the opposite of the way you brought it in. You unhook it, you float it out, and you pull it up in one straight line, pulling your curtain part up to your float as you go.
Okay.
And when you pull it out, you've usually left it in place for a while after you finish your project. So the hope is that all of the turbidity that you created, all the sediment that might be floating around in there, has settled to the bottom and won't be released out into the lake when you're removing it.
Great. All good information. There are a lot of questions here. So I'm going to try to go through these quickly because we are a little bit over time, but I want to get to everyone's questions because these are really good. So if you were working on Lake Champlain, would you start your installation at a predetermined elevation based on historical flood levels?
I mean, can you re-ask the question? Let's see. If you're working on Lake Champlain, would you start your installation at a predetermined elevation?
Based on historic flood levels.
That is a question that I would pose to a designer, potentially. We usually come to this project after a lot of the would you do this or that questions have been answered. So yeah, I'm not really sure how to answer that question.
All right. I've been asked whether coir material could release salt into the water or be toxic to pets. Are either an issue for coir logs or blocks?
Not to my knowledge. As far as I know, they're entirely made of coconut husks, and it's a biodegradable material. And while it's not a native biodegradable material, yeah, I'm not aware of any sort of issue of toxicity associated with them.
Okay. I would doubt it also. This person says, we have a similar situation on Maidstone with ice damage. However, there are two large stumps that create a problem. They're eroded underneath the stump and will not allow to be filled underneath the root structure. Would it be possible to remove the stumps, regrade, and slope using the coir logs?
I feel like that's in part a permitting question.
Yeah.
Is it physically possible? Yes, totally. Would it be allowable? That I don't know.
Yeah, maybe is the answer that I have for you. And I don't know that Laura had to jump off the call, so she's not here to answer that. But if you'd like to email me that question, Jeff, feel free to do that. This is just some other really nice stuff about Meg and her work. I do think do you have a list of preferred woody species for these installations?
Usually when I'm looking for species lists, I look to the Allison's very beautifully redesigned lakeshore fact sheets. There's a lakeshore vegetation one that,
Yep.
Allison, do you want to direct folks to that?
Yeah, I will stick it in the chat after this Q&A section, but there's a couple of Lake-wise fact sheets that have lists of native plants and what kinds of soils and exposure they're good for. Okay, how do soil lifts hold up to flooding or ice push immediately after installation before the roots are established?
So that's part of the reason that we have those bio-D blocks and stone toes in place to protect the soils and the slope as the plants are getting established. So the block at the front of the encapsulated soil lift, that's supposed to help make sure that your soil's not just flowing away when there's any sort of like rain event or flood. The geotextile around the stone toe is also supposed to help make sure that your soil and your lifts doesn't just flow down and out into the lake or into your to fill the voids in your stone toe. And the toe itself helps with that ice push, as I mentioned earlier.
Okay, great. I think this next question is about the turbidity curtain. What is it weighted down with, and does the weighted material go into the lake, or is it removed?
It is weighted with that chain that we mentioned, and then every once in a while, if we have some relatively wild wave action, we'll sometimes take a stone, if it's already on the lake bottom there, and just sort of set it in place. We'll sometimes stake our bottoms down if it's shallow enough, but it's mostly that chain that holds it down, and it tends to work pretty well.
Okay. I'm going to answer this next question. Is there any state or program that assistance offered to residents willing to change from a bad shoreline control to one that's more environmentally friendly? Yes, there is the Lake-wise program that we're going to talk about later in this presentation a little bit. That is a free technical assistance program for lakeshore landowners to learn more about how to manage their property. And then there's also funding opportunities for implementation of those projects. All of that's going to get covered this afternoon, so I don't want to talk about it too much right now. And last question, regarding the question about stumps, what is the answer if fill can be placed under the stumps? And would the method you showed placing soil lifts around the birch tree work with placing soil lifts around stumps that are still part of the bank if the roots are anchored in the natural berm?
Yeah, that's absolutely something that could be done as long as it was permitted. Yeah, it would be a little bit more difficult if there was any sort of sloping back required, because you wouldn't be able to slope back in the spot where the stump is. And if you had to slope out, then that would require that lake encroachment permit. But yeah, it could be done.
Yeah, that's the last question for this because we're running about 10 minutes over time. So thank you, Meg. That was a great presentation. Really informative, fantastic pictures. I always like hearing about how these projects actually get installed. And our next presenter is Annie White of Nectar Landscape Design. She's also a professor at UVM. She's going to talk to us about native plants and why they are important in these bioengineering projects. Oh. So Annie, we can't hear you. It's not showing you as muted, but I. All right. While Annie is figuring that out, there was a question in the chat about funding for municipalities and not residences. Yes, there is funding for municipalities, and we are going to get into, the funding opportunities for these projects after lunch. But yes, funding can go to municipalities. And is it required that PE designs these soil lifts? I'm not sure what you mean by PE. So like a engineer? Guess I'll turn on my camera so you guys have something to look at. Professional engineer. It probably depends on the difficulty of the project. A lot of the times these are designed by professional engineers, at least at the 100% design stage. So I'm not sure if there's like a written rule about that, but most of the time they are. Are there any other questions that I can answer for y'all while we wait for Annie to get back on the call? Otherwise, you're just looking at my face.
I would chime in about the engineer question. I think typically, there are degrees of risk that people are willing to accept or not accept, and liability follows that person. And so I think there's discretion for the designer to whether or not they require PE. If it's on like a town highway, kind of like that Black Pond Road, it wouldn't be a bad idea. Also, I think there are rules about like retaining structures. So retaining walls over 4 feet typically have to be engineered and stamped. So kind of all depends.
Yeah, I think sometimes you might get like a buffer planting project or something like that that wouldn't really require an engineered design. But yeah, for the more intense projects or some of the project types, a professional engineer is more required. All right, Annie, I saw you came back in. Are you here? Can we hear you?
I'm here.
Yay, we can hear you.
Okay.
Great.
I didn't do anything. All I did was log out and log back in. And then, of course, I was like, oh, no, where's the link? I don't know where the link is to get back in.
Who knows? There's so many people on this call that a couple things have gone a little wonky.
Yeah.
All right, I'm going to turn my camera off and let you take it away.
Okay, let's try this again. Okay, let's see. I am not seeing. I don't think I'm sharing here. There we go. Okay, can you see my slides and hear me this time?
Oops, I'm muted now. Yes, we can see and hear you.
Okay, great. This over here. Okay, thank you, everyone. Thank you for your patience. I am Annie White, and I am an ecological landscape designer. I have a couple of different hats. I teach full-time at UVM in the Plant and Soil Science Department, teach mostly landscape design, horticulture, some agroecology courses. And then also on the side have a design studio called Nectar. And I specialize largely in lakeshore restorations. Also note that I'm a little under the weather today, so apologies for the voice. Hopefully it will hold up for 30 minutes here. So I am here today to talk specifically about the role of using native plants in the shoreland restoration practices and talk about why they're so important to use as opposed to non-native plants. And some of the benefits that they provide and why, and also share some resources to help you as you learn more about selecting native plants, sourcing them, and learning more about the roles that they play. So as we get started here, want to take a couple minutes to define a native plant. There are a lot of varying opinions on how to define a native. We could spend a lot of time talking about this. Even for myself, I will use sometimes a different definition of a native plant depending on what kind of a project I'm working on, whether I'm doing a strictly residential project or more of a restoration type project. The more conservation oriented a project is, I'm probably going to use a more stricter version of what native really means in that project context. The USDA definition of a native plant is one that's part of the balance of nature, has developed over hundreds or thousands of years in a particular region or ecosystem. And then a definition that I like, this was fairly recently written by Dr. Doug Tallamy. I'm going to bring his work up several times in this presentation. He takes it a little step further, saying that a native plant is one that has evolved in a given place over a period of time, sufficient enough to develop these complex and essential relationships with the physical environment and other organisms in a given ecological community. So with this, he's really getting at the role that native plants play in an ecosystem, that it's not just about the fact that the plant has been there for a long time without human intervention, that really the importance of that native plant has to do with how it fits in and the role that it plays in the broader ecosystem, the relationships that it's built with other plants and other animals within that ecological community. Now, how do you know if a plant is native or not native? Unfortunately, they don't all come with little flags saying that they're native or non-native. So a few different tools that I use. One that I use really frequently, and I use this a lot as I was starting to learn which plants were native in Vermont and in New England, it's called the Go Botany tool from the Native Plant Trust. They're an excellent nonprofit that works with native plants based out of Massachusetts. So this Go Botany database, you can search for plants within it, and the database has essentially every plant that's native in New England. If you search for a plant there and it's not there, it means that it's not a native plant in New England. And it includes these maps, which are really helpful, showing the New England distribution. So you can see county by county where this plant is considered native, and this data has been accumulated from historic botanical records. And then it will also link to this national database called BONAP that database includes the distribution of these plants throughout the US. Sometimes you might search for a plant and find that it's not native in New England, but it may be native to the Midwest, and you could find that in BONAP. So a really important part of defining a native plant is to give it some kind of a geographic qualifier, because just saying native really doesn't mean anything until you define what you mean by native. Do you mean native to North America, which is a really broad definition, really broad geographic area? Do you mean native to New England, which is still relatively broad area? Do you mean native to Vermont, or even getting down to your exact county and your exact project location? So again, the more conservation oriented a project is, I tend to use a narrower definition of native. If I'm doing a a real restoration project on the lakeshore, I may be trying to use plants that I know are native to that exact location. If I'm doing a pollinator garden in a suburban backyard, I might include some Midwestern natives in there, even though those plants did not historically grow right in that location. Now, I mentioned geographic qualifiers, but another aspect in that is that we tend to put political boundaries on geography, right? And those political boundaries do not typically reflect the ecology of a site. So the EPA has designated what we call ecoregions. There are ecoregions throughout the whole US. This is a figure showing the ecoregions within New England. So ecoregions are areas that are defined not based on political boundaries, but rather based on their similar geology, climate, soils, hydrology, the vegetation in that area, the wildlife that's there. So when you think about defining that geographic area that you want to include native plants from, it's much better to think about an ecoregion than it is to think about your state boundaries. So Vermont, we have a couple of different ecoregions. Most of Vermont is in the northeastern highlands. The Champlain Valley is really substantially different than the rest of Vermont, and it's more similar to these areas along the Great Lakes. So we call that the Eastern Great Lakes and Hudson Lowlands ecoregion. So we've defined a native plant a couple different ways. Then, of course, there's non-native plants, which would be plants that are introduced from other areas, other parts of the world. Those non-native plants may or may not be invasive. We are much more concerned when these non-native plants are invasive. So a non-native would be, or an invasive plant would be one that is both non-native and able to establish very quickly on a site. It can spread, and to the point where it is outcompeting the native vegetation that we have, disrupting our native plant communities, and ultimately disrupting the ecosystems. And we all are familiar with some of these native plants, non-native invasive plants that can come in and really wreak havoc on our shorelands, on riparian areas. This photo, Japanese knotweed, many of us are probably familiar with that, really can take over shoreland areas if it becomes present. So that is a non-native plant that is also very invasive and should be addressed. There are lots of resources that are out there to learn more about your natives, learn more about your invasives, and what you can do to help knock them back and control them. Just one website that I find helpful is called vtinvasives.org. It has a lot of information here. All of these pictures on the website you can click on, and it will take you to a page that discusses different mechanisms for controlling this invasive plant and different methods. Many of these plants that are on this list have been introduced through the horticultural and landscape trade. So something that we as an industry have certainly learned and also need to be very cognizant of as we move forward and continue to put more plants into landscapes, is how will that plant interact in that local ecosystem. And some things work very well for erosion control, like Japanese knotweed. It certainly does stabilize a bank, but it outcompetes everything else there. And also on this list, things like a Norway maple. Those were planted really heavily because they are very tolerant and resilient in urban landscapes. And that is true, but they're also so resilient and so happy in urban landscapes that they outcompete everything else. And in general, any project that I'm doing, I'm going to be surveying the site up front, identifying any invasive plants that are there, identifying which ones need to be controlled in order to make sure that the project is successful. Because you can go in and do a perfect restoration project, put in a beautiful diversity of native plants, but if you have knotweed or loose strife or Phragmites there, it is going to be a really tough battle to keep that project successful without a lot of ongoing maintenance. So now I want to spend some time talking about the benefits of native plants. And here's a bulleted list that covers the key benefits of these native plants and why we promote their use in these shoreland environments. I'm going to talk about several of these points in more depth. But the first one, stewardship of our natural heritage, just being good stewards of our landscapes, recognizing the cultural value that's in preserving the plants that are indigenous to this area. Secondly, promoting biodiversity. That really segues into the third one, that our native plants are, in most cases, the preferred host plants for our native insects and pollinators, as well as a food source for native birds. I'm going to talk more about that. They have very deep root systems, typically. I'm going to talk more about that shortly. They are adapted to our local soils and climate. So when you're selecting plants and you may have some tricky conditions, whether it's really clayey soils or higher saturation in those soils, looking at the plants that have historically grown in those conditions for hundreds of years is a great tool for just being able to recognize which plants are going to be the most successful on that site. Once plants are established, they should no longer require long-term irrigation. I should note that any plant that's going into a site as a plug or a potted plant, that's an unnatural transition for that plant to make. So they are going to need some short-term irrigation in that first season or two until they can get their roots established. And they should not require any long-term additional nutrients, additional fertilizer. So going back to the point of native plants having deep root systems, this is a figure that is in the bioengineering manual. Didn't mention this in the beginning, but I'll mention it now that I think of it again. I was involved in the pulling together this bioengineering manual. I did also back in, don't remember if it was 2016 or 2017, I did some part-time work with DEC in the Lakewise program when Amy Peacock was there. And we put a lot of effort into trying to get more case studies of these bioengineering practices on Lakeshore. So that's kind of how I became really involved in the Lakeshore work being done here in Vermont. So anyhow, this figure is from that bioengineering manual. And all of the illustrations are so nice in that manual. Holly Greenleaf did the illustrations. So this figure is showing on the left a couple of our most common non-native ornamental landscape plants, daylilies and hostas. You can see they have certainly a root system, but not terribly robust. And then next to those, you see turf grass. So turf grass has a very shallow root system. It's why it's so prone to erosion. It's why grass is the first thing to dry out as soon as it gets hot and dry in the summer. Typically what you see above ground is reflected in the root system below ground. However, if you compare that to some of our native plants, many of our native plants, especially the grasses, they have phenomenal root systems below ground. They hold oftentimes more biomass underground than they do above ground. And that biomass that they keep underground is what makes them so resilient in the landscape and really tolerant of periods of drought, tolerant of periods of inundation, makes them fire tolerant, which is how many of them evolved in landscapes. And so in these lakeshore settings where a huge part of the use of plants is to hold soil in place, these more robust native plants with these big fibrous root systems can be really, really helpful. So the real key players here, a couple of our native grasses, switchgrass, little blue stem, big blue stem, those all have root systems that are 6, 7, 8 feet deep once they're fully established. So really, really robust. Another big benefit of native plants that I just mentioned is the role that they play in the whole ecosystem, the way that they support the food web. So native plants on a whole are the preferred food sources for native birds and the preferred host plants for native insects and pollinators. There are always some exceptions where there are some non-native plants that are also good food sources, but on a whole, the research shows that our native plants are really, really important for supporting a lot of this native wildlife. And the whole foundation of the food web really starts with these native plants that the native insects can eat off of. There's been a lot of really excellent research done in this area by Dr. Doug Tallamy at the University of Delaware. I know I have another slide coming up that shows a couple of the books that he's written. And he's in the mid-Atlantic states and has done a lot of surveying of introduced non-native plants in the landscape and comparing those to our native plants and how well they serve as host plants for native insects. And he particularly looks at caterpillars. And so caterpillars are the larval phase of moths and butterflies, and they are a super important food source for birds. So this is, in this image here, we're looking at a couple of different dogwoods, one being native on the right, our flowering dogwood. That is really only hardy in the Champlain Valley in Vermont. But seen all up and down the mid-Atlantic states and the eastern seaboard. And then on the left is a non-native dogwood introduced from Asia, the Kusa dogwood. And I see Kusa dogwoods all over the place here, very common front yard specimen tree. They have very similar forms in the landscape, can be used really similarly. But according to this research that was done, Tallamy found that the non-native had 0 caterpillars on it. When they would look at all of these trees and collect insects that were on them, there were no species of caterpillars. However, on the native, they found 117 different species of moth and butterfly caterpillars. Now, where this gets really tricky is that when you're in a nursery setting, and in a more ornamental type landscape, there may be an appeal towards the plant that's not going to have any leaf damage on it, that's not going to be supporting things that are eating it. However, that native dogwood that has the leaf chemistry that's palatable to all of our native insects is incredibly important for supporting the food web. And we really have to shift the way that we think about insects on plants and the way that we tolerate leaf damage on plants. And if something is not eating the leaves of your plants, then it's not really playing a role in the ecosystem. Of course, there are exceptions where we do have some pests. Many of those pests are non-native that may defoliate trees, but the vast majority of insects that are out there, vast majority of leaf damage is being done by just native caterpillars. So shifting the way that we think about leaf damage and having more tolerance of it is really important as we plant more native plants. We are probably all familiar with the specialist relationship between the monarch caterpillar and milkweeds. The monarch needs milkweed species in order to be able to reproduce. The caterpillars eat only milkweed and will they just heavily rely on that plant. They cannot complete their life cycle without that plant. But that's just one example. 90% of our insects have evolved to be plant specific in some way. The monarch is just one case of that. Juniper hairstreak on one red cedar, that's sort of a more obscure example of this, but there are thousands of examples of similar relationships where our native insects really need these native plants. And then furthermore, getting back to the bird connection and the connection to the whole food web, 96% of birds depend entirely on insect protein to feed their young. So many of us love to see songbirds in the landscape. Nearly every client that I work with on a lakeshore, it usually gets excited when I start talking about supporting more birds. And we often think that it's the bird feeders and the bird seeds that these songbirds rely on. But the truth is they really heavily rely on insect protein to feed their young. Just the chickadees alone, 146 trips per day to feed their young. They collect up to 9,000 caterpillars to feed a single clutch of their offspring. So they are heavily reliant on our native plants in the landscape. So really the best thing that you can do to support birds is not to put out a bird feeder, that can be supplemental, but to plant more native plants. And by putting the native plants out there, those will support the native insects, and that becomes the food source for the birds. And then that energy will work its way entirely into the food web and up the food chain, if you will. There's also a really strong correlation between having native plants along a shoreline and the diets of the fish within the lake. So if I'm working with clients, if I can't get them excited about the birds, I usually can get them excited about the fish. And many people aren't aware of how important that insect protein is for fish in the lake. There have been some more detailed studies done in the Pacific Northwest, finding that direct correlation again between how developed a lakeshore was and the diets of the fish within the lake. So the more developed a lakeshore is, the less plants are along the shoreline. They found that in highly developed lakes that the diet of these fish had more than, or I should say less than half the amount of energy that they would normally get from insect protein. There are a lot of resources that are out there now to help you learn which plants are the best host plants in the landscape. So we call plants a host plant if it's a plant that's going to support insects. Much of this information, again, is coming from Talamy's research. This chart is showing the top woody plants and the top herbaceous plants in terms of supporting moth and butterfly species and those caterpillars. Oak trees top the list of woody plants. On the herbaceous side, surprisingly, goldenrod is at the top. So many folks think of goldenrod as a useless, weedy species out in our meadows, but it's actually an incredibly important host plant. Those goldenrods and asters right at the top of the list. So Talamy, he wrote Bringing Nature Home, which was first published, gosh, quite a while ago now, might have been 2009. And he is a really inspirational academic researcher, but somebody who's taken the research that he's done and put it into really engaging writing and books that the general public and the general gardeners can enjoy and learn a lot from. He has a newer book called Nature's Best Hope, which is a great read. Highly recommend it. My students are reading it right now. This is one little quote of his that I like, that I stuck up here. In the past, we have asked one thing of our gardens, that they are pretty. Now they have to support life, sequester carbon, feed pollinators, and manage water. What he advocates for is encouraging everyone who owns property of putting more care into what we plant into that landscape, really fostering the success of native plants, and how important that is, because we do not have enough preserved land out there. And his initiative here, called Homegrown National Park, is an effort to get folks in their own backyards to preserve area, to improve biodiversity, and then collectively trying to create the largest national park by doing that. And we just don't have enough land in preservation in our national parks or other preserved areas to maintain biodiversity. So we need to take better care of our residential and commercial landscapes. There's a lot of multifunctionality that can go into planting on shorelands. Oftentimes we may be going into a project with an eroded shoreline, and the key goal for the project is to stabilize that shoreline. But we also know by stabilizing that shoreline and using native plants, we also can be supporting pollinators at the same time. So even if that's not necessarily a goal for a client I'm working with, I know that I can have an added benefit to the project just by using native plants that are flowering, making sure that I have plants that are flowering throughout the full growing season so that there are food sources for a diversity of pollinators throughout the whole season. And we can do the same with birds as well, like using native plants, but also having using some shrubs that have berries, having some nesting habitat for birds as well. So a lot of benefit to the broader ecosystems using these native plant-based practices. A tool that you can use if you are new to using native plants and looking for more direction, of course, there are resources that are out there, like the fact sheets that Allison has through the Lakewise program, which are an excellent place to start. Another place that you can go is again, the Native Plant Trust and their Plant Finder tool. And this allows you to put in your site criteria, like your sun exposure, your soil moisture, the ecoregion that you're in, put in some other characteristics of what you're looking for, maybe the benefits that you're trying to achieve, and then hit a search button and it will pull up native plants that will meet the criteria that you put in. So great tool if you're, again, new to using native plants. It's a good place to start. One thing that I always advocate for is using the local ecosystem as a model. And really the safest plant choices that you can make, and probably the best plant choices that you can make to be successful on any given site, is to simply look at what's already growing there in areas of a lakeshore that are not disturbed. So going out onto a lake, looking at what native plants are along that shoreline, and I always do that on every project. Plus, it's a great excuse to get out into my canoe for the day and paddle around and collect this research. And not just with plants, it's also great to see stable areas that are naturally stable and what's going on with the rocks on that shoreline. What type of slopes am I seeing? So use local ecosystem models as much as you can to help inform your designs and your plant selection. Going back to some problems with turf, in addition to having very shallow root systems, which make them very prone to erosion, they also just are a real desert when it comes to habitat value. They're not providing any kind of value for that native wildlife. Now, I will accept that they do provide some recreational value. So I don't think I have yet to have, the wheels are spinning here. Have I had a lakeshore project where the homeowner's been willing to get rid of 100% of their lawn? I think I've maybe had one, but typically lawn still is an attractive solution for providing a functional space for gathering, for sitting, for kids, for pets to play. But it's really important that we think about how much lawn is actually needed and try to match that amount of lawn to the function. And trying to then, whatever area does not need to be lawn, trying to put that back into native vegetation that's going to be very stable, that's going to soak up more stormwater, help stabilize the shoreline, provide that wildlife habitat. So make sure your lawn areas are intentional and functional. And here's just one example of a site that was really entirely lawn on this whole peninsula, and mapping out, again, working with the homeowner and talking with them about how they use the different spaces, how much space they feel like they need, where they would like to see pathways, and then trying to come up with a solution that minimizes their lawn, still provides them with the functions that they need. This is a photo actually of that site, showing a lot of that open lawn space. This project did include some shoreline restoration and just some plants starting to grow in here. And one tool that I implemented with this project with the help of Holly Greenleaf here is this is a photo simulation. So this is not real life going from this picture back to this picture, but sometimes these photo simulations using Photoshop are a really good tool to help homeowners understand what a landscape can look like, because there's so much hesitation I find around putting more vegetation in that could potentially block views. Views seem to be, I would say, the #1 concern of homeowners on their lake shores. They want to do the right thing. They want their shoreline stabilized, but they don't want to obstruct any views. And trying to get them to see how we can actually make views more interesting, how we can frame views, enhance them in a lot of ways, have a lot more movement and a more dynamic experience within their landscape by having more vegetation, by having wildflowers. And we can plant trees and the trees will grow up and you'll see through their trunks and we can actually frame views. We can create more diversity within the views on the property. But that can, sometimes it's nice to use these little tricks like Photoshop to help people to visualize what these changes could look like. Another tool that I encourage folks to use, again, as we are trying to promote these landscapes that are truthfully a little bit different than the cultural aesthetic that many folks hold. So many of them are used to much more manicured landscapes with a big green lawn and some mulched beds and some non-native hostas and daylilies. And these practices that we're promoting that they are going to really live with and within can be a very different aesthetic than what they're used to. So adopting some tools to kind of encourage them to love these landscapes and to interact with these landscapes in a positive way is really important, because we have to recognize that aesthetic and ecological goals and values are sometimes positively correlated, but not always. Also, attractive and admired landscapes are much more likely to survive than landscapes that do not attract the care or the admiration. So it's so important that every client I work with falls in love with their landscape, because if they don't, they're not going to maintain it. And if they don't maintain it, they're probably going to get rid of it. Probably 5 years, it will be gone. So really important to give them the tools and sometimes make compromises to make sure that they love and they care for their landscape. One like quick little tip: messy ecosystem, orderly frame. Sometimes putting an orderly frame around something that is a little bit more wild, more diverse, something like a native plant meadow. If you put a fence around it, even a very short, really a visual fence, a visual barrier, can make that area look intentional. A low stone wall, even just some cedar edging, can really help make the bones of the landscape, like the structure of the landscape, look really intentional and well thought out. And then that allows the rest of the landscape to appear a little bit more wild. And also personalizing the plan, I think, is really important. So again, that's a compromise to allow people to really love their landscape. So if somebody comes to me and says, well, my very favorite plant is this Asiatic lily that my grandmother has grown for decades, that Asiatic lily is not going to provide any ecological value to the landscape, but if having some of them in the landscape is going to help my client appreciate and love this landscape and maintain it, then that's a win. Okay, just recapping here some of the resources that I mentioned. A lot of resources out there through the Lakewise program. Federation of Vermont Lakes and Ponds also has some good resources. I mentioned to determine if a plant is native or not, the Go Botany tool through the Native Plant Trust, or looking outside of New England, BONAP, and also the Native Plant Finder tool through the Native Plant Trust. And I think the Lakewise program has done a phenomenal job in trying to inspire a new culture and a shift in aesthetics along Lakeshore. So the more people we can get involved in this program, I think the better, and the more examples we have of these more vegetated, more diverse landscapes along shorelands, the more people are going to see that, recognize it for its ecological value for the lake, and also that it's beautiful. And not everyone may be willing to go this far in terms of revegetating and establishing a shoreline buffer. But if we can get more and more lakeshore owners to take some steps in this direction, it will make a really big impact on water quality and the overall ecology of those sites. Okay, so that wraps up my presentation. If you have any questions, I can take questions, I think now, maybe a little over time. And my address is down there as well.
There's a couple questions in the chat for you.
Okay.
Let me scroll back up here. There was a lot of conversation about something you said about knotweed and its ability to stabilize the shoreline or not. Do you want to clarify anything about that?
Well, I don't know what the questions were, but I will clarify. I in absolutely no way suggest that anybody plant it to stabilize the shoreline. It is a very bad invasive plant, and it outcompetes everything. So probably, yeah, if you probably compare knotweed to a diverse native shoreline, it's not going to stabilize it as well as a shoreline. I guess I pointed it out as an example of sometimes non-native and sometimes invasive plants can have a single value. Another thing is knotweed is when it blooms, it actually does provide nectar and pollen to bees. Also, something like Phragmites also stabilizes shorelines, but again, it outcompetes everything else. So there's still a net loss.
Yeah.
Ecologically.
I think the conversation ended up as better than a bare bank, but not much better.
Correct.
Yeah. So another question here: will native plants with large root systems overtake invasive species?
I would say it's case by case. Unfortunately, there are some invasive species that just will outcompete everything. I think the more we plant, the more densely we plant in areas, that's going to be a big help, because a lot of our invasives are very well adapted to coming in very quickly on disturbed soils. And so making sure that we plant solidly anytime there is a disturbance and soil is exposed, of trying to get native plants and to stabilize that soil.
Okay. Great. So I put some of our Lakewise fact sheets in the chat with native plant lists. I also put a list of native plant suppliers in the chat. That hasn't been updated in a couple of years, so take that with a grain of salt, but there is a list there. I also mentioned that a lot of NRCDs have plant sales, and then a couple more people chimed in with their local NRCD's plant sale information. So there's a lot of good information in the chat about where to find native plants if people are looking. And This looks like maybe more of a comment. Japanese knotweed invasion in Stowe. We found willow trees are holding their own with the knotweed along a portion of the Little River. So that's great to hear.
Great. Yep.
If there are any more questions for Annie, I put them in the chat now or ask your question. Otherwise, we are running a little bit over time, but this is our scheduled lunch break. So we are going to take a half-hour break and we'll meet back here at 1:10. So last call for questions. Maybe everyone's really hungry. I know I am. All right. Thank you, Annie. That was a great presentation. Oh,
Welcome.
someone just raised their hand. Jack Brooks, would you like to ask a question?
Yeah. Well, second to the last slide. What was that guy standing on? What kind of grass was he standing on?
In the last slide?
The Lakewise photo, I think.
What was the grass? I'm not sure I know. Oh, in the Lakewise photo. I don't know. I'll share the photo again. Maybe somebody else knows. There's a lot here. There's loads of grasses, loads of sedges, ferns.
Yeah,
The
there's a
photo.
lot in that photo.
Yeah. I'm not sure I can.
I mean, this tall grass looks sedgy.
Yep.
And was this a no-mow area?
Yes.
Do you know? Yeah, so this is just what came up in this guy's lakeside property when he didn't mow it. Beautiful. Sorry, we can't be more helpful in identifying the grass. All right, let's break for lunch, everyone. 1:10, we'll reconvene. No-mow area, Christine, that's not a cleared area. I don't think anyway. I don't know if Laura's back on this call, but I would consider that vegetated.
Yeah, once an area is unmaintained and a no-mow, we consider it vegetated.
Stay logged in and we'll just let the call sit for half an hour. All right, great. Thank you, everybody.
Bye.
Bye.